Start. Good afternoon, all. I think we'll start. People are joining. Let's start the program. Place to commitment to continuously improving knowledge, process, and collaboration with the foundry industries. The program like this webinar play a vital role in helping us stay updated with emerging technologies and best practices. And today's topic knows tomorrow's and chemistry today, how AI-driven physics is replacing guesswork in green sand management. Extremely relevant for our industry. In our foundry operation, many of us losses we face are often hidden in areas where we do not fully measure or understand. We don't know. With the increasing pressure on qualities, productivity, and cost competitiveness, it's important for us, the foundries, to adopt data-driven approaches where we are lagging and advanced technologies. Understanding sand chemistries and controlling its operational efficiency. And we are privileged to have with us today Mr. Vijay Gurunath, CEO of Refcoat Chemicals Private Limited, as our guest speaker. Mr. Vijay, all you know, a well-known figure for the industry. Vijay brings deep expertise and industry insights. And I'm confident that today's session will provide valuable takeaways for foundry entrepreneurs, operation leaders, and technical teams. I only request all the participants to actively involve and engage yourself and understand what way this webinar is going to help. Maybe the learnings can be put in your day-to-day operation. I once again warmly welcome you all and thanks for joining today's chapter past chairman, Mr. Vignesh Ramanan.
Thank you, Chairman. Good afternoon, fellow Foundrymen. It gives me immense pleasure to introduce our speaker for today's webinar, Mr. Vijay Gurunath. He's not only a respected professional in our foundry industry, but also a family friend and a well-wisher of mine. Mr. Vijay is the CEO of Refcoat Chemicals, founder of Forecast Platform, and also the founder of Carbon Without Borders, LLP. He's actively involved with the Institute of Indian Foundrymen and serves currently as the Vice Chairman of the IAF Bangalore chapter and also as a council member of the IAF Southern region. A chemical engineer by qualification, Vijay holds a master's degree in chemical engineering from Missouri University of Science and Technology, USA, where his research focused on nanoparticle synthesis and delivery mechanisms. Over the past 2 decades, he has built deep expertise in green sand casting materials and process science. At Refcoat, Vijay has led the development of innovative products such as NanoCarb, a nanotechnology-based carbon additive used in foundries across India and Europe, and MoldMax, a patent-pending technology designed to change how bentonite interacts with water at the molecular level. His latest initiative, Forecast, is an AI-driven diagnostic and prediction platform designed specifically for foundries. Using daily laboratory data, the platform learns the physics of each foundry sand system, helping predict key parameters such as active clay, LOI, moisture, compactability, and green compression strength, that is GCS, while also diagnosing root cause analysis when properties drift and recommending precise material adjustments. Vijay has trained foundry teams across India and Europe on green sand fundamentals, and through his initiative, Carbon Without Borders, he is also working on carbon compliance tools to help Indian foundries prepare for upcoming CBAM and ESG requirements. In today's session titled Know Tomorrow's Sand Chemistry Today, Vijay will share insights on how AI-driven physics and data analysis can replace guesswork in green sand management and how foundries can unlock hidden efficiencies using the data they already collect every day. Gentlemen, please join me in welcoming Mr. Vijay Gurunath. Vijay, the floor is yours.
Thank you, Vignesh. Let me start by sharing the screen.
Yes.
And I'd like to take this opportunity to first thank IIF Chennai chapter and Bangalore chapter for giving this platform so that I could share the insights that we have right now. Heartfelt thank you for that. And is the sharing visible? Are you able to see it?
It went back. Can you share it again?
Is it visible now?
No, Vijay?
No, not yet.
Okay. Okay. Yeah. No, once you go into presentation mode, it's coming out.
We just tested this a little while back with Dinesh. I'm sorry. Let me just try it again.
Yeah. No.
Is it visible?
No, it's coming to the screen, and then when you press on present, it's getting closed.
Any idea on what I can do?
Yeah, do you want to share the file with me? Do you want me to try? And you can speak, and I can just change the slides.
Let me try this one more time. Are you able to see the screen now?
Yes, yes.
Now?
Yes, perfect. Go ahead.
You can see the full screen, correct?
Yes, yes, yes.
All right. Yeah, sorry for that hiccup. Yeah, like I was saying, good afternoon, everyone. Thank you for making the time out to come and attend this webinar. I really hope that you get a lot of value from this webinar today. And what we're going to talk about is, something according to me is very innovative and very unique and at the bleeding edge of green sand science right now. What we want to try and achieve is to see if we can know what is going to happen to the sand tomorrow, to the green sand tomorrow, how the properties going to change, what are the properties going to be. And the reason why we need that is because every foundry has the same problem every single day. Yesterday's green sand properties look perfect in the lab charts. Every range was in control, all the parameters were in range. And yet today we see that the castings have some pinholes, some rough surface, some defects. So why is it that the rejections grow even when the lab report says green? And I think that's $1 million question that Foundrymen have been trying to solve in centuries now. And one of the main reasons for this is that we are driving the green sand by looking at the rearview mirror. Now imagine you're driving a car, but you're not looking forward, but you're looking at the rearview mirror and driving it. It's going to be definitely difficult, and you are bound to make mistakes, and you're definitely going to have an accident or two here and there. Right? So relying purely on lagging indicators is almost like gambling with your production plan, because the data that we have is from sand that is already prepared out of the mixer, and the rejections that are associated with it are 1 or 2 days old. And using that data, we are trying to decide what needs to be done today and tomorrow so that we rectify those mistakes. And most foundries say that if the lab charts are green, then it will continue the same as yesterday. Or sometimes you add a little extra bentonite, a little extra carbon, just to be safe. And this typically not only messes up the physics of it, but also results in a lot of raw material wastage across a foundry. And one of the biggest challenges that foundries face that have extensive data and all of that is this classical trap of confusing correlation with causation. I want to spend a few minutes here trying to explain this. To give you an example, my son is 13 years old, and he's one of the shortest in his class. And my wife is worried that, he's not growing, he's not growing. And then somebody said, why don't you try giving a protein supplement, you know, that will make kids grow. And sure enough, she got home some protein supplement and started giving him from about, for 2 months. And sure enough, he started growing, and he started becoming tall. Now, if you look at it, is there a correlation between protein and my son's growth? Yes, there's 100% correlation that he's growing once he started with the protein. But is protein what is causing that growth? And the answer is no. What causes his growth is the genetics and the DNA. And it's just that this was the time, and he probably was a little late bloomer, and that is all it was. But if we look at it purely from a statistical point of view, then we confuse the growth with the protein supplement. And there are a lot of examples on the way, and this is a very popular example. In summer, the shark attacks increases, and so does ice cream sales. So is there a correlation between ice cream sales and shark attack? Yes, 100%. But is ice cream sales what drives shark attacks? Absolutely not. So the correlation and causation are two very different things. And usually when we try to overuse statistics, we confuse correlation with causation. And I think that is something that traditionally happens in a foundry also, not because we want to, but that's how the entire system has been wired. So we see that when bentonite goes up, GCS goes up, and statistically we assume a rule. But in reality, we don't know why. What was the reason that GCS went down in the first place? Was it thermal degradation? Was it dead clay? Was it free moisture change? So we try, without understanding what really happened, we are trying to use past correlations to see if we can fix a problem that has come up. And the failure with this method is that when conditions change, when raw materials change, when there's a seasonal change, the pattern recognition cannot tell you which lever to pull. We simply have no idea why this is happening today. It might not have happened probably in the last 6 months, but something happened today. And that's one of the fallacies of looking at the rearview mirror and driving. Right? But if we look at it, why is it such a challenge? For example, if you look at you know simulation tools that are already in use, for example, there's physics-based metal simulation that's popularly being used. Casting simulation software does not use statistics. It understands cause and effect. So when you use a casting simulation software, it need not know how many or what was the castings that you produced last 6 months back. It needs to know what is it that you plan to do tomorrow, or what is the kind of pattern or the casting that you're trying to develop. And it uses physics and first principles to simulate what is going to happen. Right? And if you try to do the same thing with green sand, that it becomes even more challenging. Casting simulation itself is very challenging to simulate, but when you go to green sand has multiple other dimensions. The first thing is green sand has a memory. We circulate the same green sand multiple times over a day. And every single day, we make a small addition to that sand system. And at the same time, we are removing part of that out of the sand system. So at any point that you measure, you're not measuring the entire sand system in totality. You're getting a snapshot of what it is in that mixer and that batch. So if we have to predict what happens tomorrow, then we must account for this memory. We must account for the thermal history, the granular medium, the porous medium, the changing boundary condition. And most of these important variables are directly not being measured in the single standard lab test that we do today. So this is probably one of the main reasons why green sand casting simulation really hasn't picked up or hasn't come out in a way as metal simulation software does. So just to give you an idea, I'm not going to walk you through the physics and the equations of this, but everything that we are able to do tomorrow can be traced back to the physics first principles, using equations, using what is already established very clearly by physics. It's just that the mathematics is extremely complex, and it is something that you cannot do using a spreadsheet in a foundry. And these were the reasons why we, spent decades working on this, and we've developed Forecast. Forecast is a dedicated digital green sand expert that transforms your foundry from reactive troubleshooting to proactive optimization. And it performs the same way exactly as an experienced sand technician or a manager or a quality manager would do, would use the same logic, would use the same reviewing techniques, but it also has the insight of physics behind it that adds it a lot more value. And it operates 24/7. It maintains a perfect memory across all shifts, and it only gets smarter with every single day of data. So what is it that you need to do to know tomorrow's sand chemistry, or what is it that a foundry needs to input? So basically what you need is, what is your production plan for tomorrow? And most foundries know how much metal they're planning to melt tomorrow. And what's the core sand that's going to get added into the sand system tomorrow? Comes from your production plan. And then every foundry does standard lab tests, your VM, LOI, total clay, active clay, GCS, permeability, compactability, moisture. And this is all the input forecast needs. And once you give this today's sand properties and tomorrow's plan, it gives you an output of what tomorrow's active clay will be, what tomorrow's LOI will be, and a ton of other things, including gas risks, scabbing risks, what is actually going to happen to your sand even before you make a single batch out of this. And the best part is that your operators receive an exact daily target of the premix. So based on this knowledge of today's chemistry and tomorrow's plan, Forecast generates a plan for tomorrow, taking into consideration all the parameters, and gives you an exact batch by batch recipe. And if you have multiple mixers, it says, okay, this is the formulation that you need to maintain, or recipe you need to maintain in mixer one. And this is the recipe you have to maintain in mixer two. And this is going to be your predicted active clay, predicted LOI, and your predicted GCS. And along with that, it shows you an accuracy metrics of how accurate it has been on your last few days, so that you don't blindly test it and you actually know what is if it's really working or not. And this delivers actionable targets directly to the operator, eliminating guesswork and any shift-to-shift variations that is there. And this is a precise recipe that can be followed, not an abstract thought that what do it. But you don't have to actually trust forecast. So what we have built, because we have built it from physics and first principles, is something of a flight simulator for sand that puts you in command. So once we generate a recipe, you have an option to play around with that recipe. You can say, okay, if I want to change bentonite, what will happen? If I want to change water addition, what will happen? If I reduce my fresh sand, what is going to happen? So you can test your own recipe before you commit. You never have to blindly follow the machine's recommendation, right? So the physics shows you exactly what will happen tomorrow's chemistry before you mix a single batch. And this is only possible because of the understanding of the physics and from the first principles. Because not just are we trying to tell you to follow something blindly, we are also giving you a chance at a platform where you can simulate and see what will happen if I make these changes. How will the science system change? How will the properties change? And with this, we are able to make sure that you see the problems days before they become defects. So based on what you plan, you're going to get a gas risk, a steam risk, an expansion risk. It's going to tell you how your compactability is going to change, how your moisture is going to vary. And if it's a problem, if your recipe is going to be a problem in one mixer, but not in the other mixer. And not only that, it is going to audit your entire system and give you alerts, give you work orders, and tell you this needs attention today. That your gases are increasing, but it's not coming from your carbon. So look at your coarse sand binders or your shakeout. There must be a problem there. And this is going to tell you days before it becomes a problem. And we are able to do a 7-day trajectory that reveals exactly where your sand system is heading. And you can predict these things before anything happens, and we can correct the trend before the rejections even happen. And that is the power of a physics-based forecast and a physics-based simulation, that you can actually see what is going to happen based on today's properties. And this is extremely easy. This does not require you to install any SCADA, any sensors, doesn't require dedicated computers and where you have tons of input coming in. This entirely works on your browser and on your desktop or mobile. There's nothing to install. You don't even need a computer for this. You can run it on your smartphone sitting anywhere. The lab user can enter data in a smartphone. You can look at uh, the analysis, the results of it in your smartphone, and you can forward the recipe on WhatsApp to your operator, all seamlessly without requiring any IT involvement at all. And this is not going to take, months to set up and years to learn. You can go from zero to accurate predictive modeling in just 15 minutes. It takes about 10 minutes to set up your Foundry. And, we have a self-service setup where you don't even need to talk to us. You can just log on and start creating your Foundry assessment and answer the questions, that simple questions about your mixer configuration, your molding lines, sand system tonnage, and the properties that you have right now, and the target of what your properties need to be. And then you upload your historic data in the template that you can download again from the website. And with 30 to 90 days, we would recommend at least 90, but 30 is the bare minimum. You can see instant model generation and forecast learns your Foundry's unique physics immediately with no complex integration. Right. But then again, after you do this, how do you know the system has learned about your Foundry? How do you know how accurate is it? How do you trust it? The only proof that matters is actually hidden in your own past data. And once you upload your historic data, the system does a back test on your Foundry data. So it uses 80% of the data that you have uploaded to learn about the physics, and sees if it can predict the next 20 days or 20% of the data that you have uploaded, using only the information what it had the day before and running as you would in a live situation. And the result is up on your screen. And you can see that your active clay, LOI, GCS, moisture, compactability, permeability, everything you get a percentage of how accurate it is. And if the accuracy is less than 95%, you don't even have to use this. You can just shut it down and just go away. There's no loss that we have apart from 15 minutes every time. And not just this, so the moment you use it for the first day, it gives you an insight. It would tell you, see, we asked you to add 18 kgs, but you added 21.9 kgs. We asked you to add carbon of so much, you added so much. We predicted the active clay of 9%, and the actual was 9.2%. The LO is 3.2, and we predicted 3.2. So this kind of accuracy is visible to you, and this kind of every single day. So every single day you enter the data, it calculates what happened. It tells you how good the model was, so that you can decide to use it or not use it. So this is not going to be a generic demo, not on someone else's case study, not on someone else's Foundry. It's going to be your numbers. And every single day is going to be a validation of the accuracy and the physics of it. And if the physics deviates, you can immediately see on the first day saying that, no, this is not what happened. So there's no trust required. It's just physics and your own data that you have. Somebody needs to be mute. Yeah, thank you. So with this, what we have done is we have democratized deep technical knowledge across the team. So you don't need to rely on a single senior expert. Forecast to make sure that everybody in your team can get the same technical insights about your science system that is backed by physics and your Foundry's unique fingerprints. So forecast empowers your operators, your managers, and your entire team to take expert level decisions even before they move single finger. Right. So with this, you can achieve consistent high quality results across all shifts, regardless of the experience of the sand plant operator, regardless of the person managing that shift. And this is what a forecast can provide for that. And this optimization of your Foundry comes with absolutely zero risk. You have a free 30-day trial with full access to the predictions, planners, simulations, and alerts. And the guarantee is that if the backtest accuracy on your own data is not convincing you, simply walk away. There's no obligation. And of course, data privacy goes without saying. Your recipes, lab values, and your Foundry configuration remain entirely yours, and there's no way anybody else can access that. And yes, so we can stop guessing and start knowing. And anybody can just log on to the website there, start your assessment, and upload the historical data. And in minutes, you will be able to see your first step towards physics-based predictive um, control. Yeah, that's it from my side. Now I'd like to answer questions. I think I hope there'll be a lot of questions.
Good evening, Vijay.
Good evening, sir.
You see, normally we are all looking at the RTC values for each tab so that every tab is being taken care of. How does this differ with the RTC and then this system what you're talking about?
Okay, so the RTC is blind to the physics. So what the RTC does is it tries to match a particular compactability and a particular moisture. So it is not aware of the physics as to why the compactability is that and why the water dosage is going to vary every single batch and what that means to your permeability, your GCS, and your castings. And this is where forecast comes in. It tells you why there is a variability in your permeability. Is that variability good, bad? How can you track it? And more importantly, how can you use these signals to tell if your sand system is deteriorating and going bad, or if it's improving towards the better way. So this is RTC is a physical control of the system, that blindly follows the logic that is being programmed into it. But this is based on physics that learns your Foundry's process, your Foundry's sentimental ratio, and the dynamic changes that happen every single day. So this is more simply more intelligent than an RTC.
You see, one thing that happens is if the foundry has got a highly variable type of load with very low core, very medium size cores and very heavy cores. Therefore, the whole thing changes in the sand, return sand bins. And it also depends upon how many return sand bins are there, how you are storing this particular sand which is coming out of the shakeout. And you see, there are many various factors how this particular forecast will handle all that.
Absolutely right. So first thing we have to understand about green sand is that green sand is like navigating a ship. It's not a rocket, it's not a Formula One car. It simply doesn't respond to changes as fast as we think it would be. Like you really, accurately said, in a foundry, there are a lot of variations in a day. The sand to metal ratio changes from pattern to pattern. Some components have more core, some components have less core. So the metallurgy, there's a change in that. But from a physics perspective, what you actually need, are the things that actually drive the changes? The principal drivers are the heat load coming from the molten metal, and then the dilution that comes from core sand. And these are the two things that you simply can't control. So if you're doing 200 tons of castings a day, you can't say, okay, now because my sand system is not good, I'll do only 100 tons. 200 tons is what you have to do. And if that requires another 100 tons of core sand to go into the system, that is what goes in. So we really can't control that. So based on those inputs, now the next question is, how do we understand the impact of this on the physics and chemistry of the sand, and how do we counter that, or how do we use that information to plan for this better? So what happens is, the reason why we ask for 90 days data is that over the 90 days, the system uniquely learns your fingerprint, your sand to metal ratio, and it is able to track if any of the parameters change because of any, for example, your core sand changes from day to day. So how is that day-to-day change reflecting in the physics of it. Does it match with the physics? And based on that, it learns. And then, so tomorrow, when you tell it tomorrow, this is my production plan, it already has a learning about your system inefficiencies, about your process inefficiencies, or even process optimizations. And then based on that, it's going to tell you, okay, this is what the physics and this is how it's going to work out in your form.
Therefore, do you mean to say that you have to give the data of the the statistics of the individual items that go in
No.
into your system, and also what has been the production on that particular day in the last 60 days or 90 days,
No.
and then the data of the green sand at what intervals?
Yes. So the data that it requires is a daily data. So for the last 90 days, we want the daily liquid metal that was done on that day, the total core sand that you added on that day, and the total additives, bentonite, coal dust, water, and new sand. All of those are daily totals that you need to upload. And we want only the daily averages of your sand properties. We don't want hour-to-hour reading. We don't want minute-by-minute reading. We want the daily averages of your GCS, moisture, permeability, compactability. And for these 4 parameters, we have under 2 more columns. What was the lowest value that day of your compactability, moisture, GCS? And what was the highest value that you had that day? And then the average. And if you do any additional tests, some foundries do WTS, GSS, variability, then you can enter those too, along with your AFS. But this is just the entire data entry can be done on a mobile phone. It's not going to take more than 2 minutes in a day. But we don't need minute details of how the pattern was, how intricate, how many kgs of core goes into this casting. No, we just want the daily average of it.
Okay, thank you. Any data available at your end regarding this implementation done and how it worked?
So like I said, so there are examples that we can share, but you can check with your own data in just 15 minutes. You can see, once you upload the data, it will give you a back test, and you can cross check and see what happened in the last 20 days, and if the software was accurate in predicting what happened with you. Or you don't even have to do it. You can just use this and simulate it for one day. You don't have to follow the software recipe and see if it's able to predict tomorrow's properties accurately. And so you can check with your own data about the software and how accurate it is and if it's going to be useful. And it takes 15 minutes for you to do it.
You mean to say the
Sorry, the voice is
one particular, all the materials is fixed for the whole day of the next day?
Sorry, I couldn't hear you. Can you please repeat that?
No, is the additions of the raw materials like bentonite or carbonaceous material, water and all that is fixed for the next day, is it? And then there won't be any change irrespective of what is there in the return sand bin?
So the idea of this is that we know what is there in the return sand bill already. The physics will tell you today this is what you produced and this is the total amount of material that you added. We know exactly what's going to be in your return sand bill tomorrow. And based on that, whatever is there already in your return sand bin and your tomorrow's plan, we generate a recipe. So now we give you multiple ways of that of showing that recipe. Let me see. Yeah. So here,
If the sand turnover is 4 times,
yes,
then what happens with respect to the bin capacity?
correct. So this was going to work even if your sand turnover, your circulation is 0.5 or 5.56. So the physics of it is going to simulate it. The heat load per circulation is what is learned, right? The dosage of that or the burnout rates of these materials per circulation per ton of molten metal is what is learned. And we exactly know how to calculate the circulation. So we know if this is the amount of circulations that you have had, the sand grain has seen elevated temperatures this many times, right? And yes, there are going to be variations because there might be some sand sticking onto the hopper that never comes out of it. So there is a damping factor that is also learned that is unique to your foundry that learns, okay, because if every single grain had to come through the sand system once, then this is how the physics would look. But your lab report says that's not how it is. So the gap is what is associated with your process, with the entire system being allocated. And then we see if that gap is consistent over time, over the last 90 days. And if there's a change, then we use physics to see if this, the physics of it can explain those gaps. And if it's not, then it's attributed to your process. So we exactly know how your process is going to behave, how your machines are going to behave, how your mixer is going to behave, um, you know, fairly accurately. And because of that, we are able to now tell you confidently that, yes, tomorrow you do this, and this is the turnout it's going to be. And like I said, even if we have 4, 7, 5, 6 circulations in a day, the sand system is not going to, because the amount of changes that you're making in terms of dosage per circulation is not very much. So if you have, say, 300 tons of sand in a day doing 4 circulations, but you're only adding about, say, 3 tons of coal dust to it or 10 tons of bentonite to it. So the quantum of additions that you do in that day has a small impact compared to what the total quantum of sand is and the circulations that is there. So yes, we can accurately tell what is going to happen to me based on the physics and the circulations.
Thank you.
Any further questions, gentlemen, for Mr. Vijay?
Like I said, I think the link is there on the web page. Anybody can just go to sandforecast.ai/assess, enter your Foundry's data, and see what happens with your own data. And you don't have to take my word for it or what the presentation says. You can just upload your own data and see how accurate it is, and if it's going to make sense for you. And of course, if you want a personal interaction, you can always feel free to reach out. I'd be happy to help. Any inputs, any feedback?
Any other questions? Shailesh. Okay. I think there is no further questions. Vijay, I think we can close it.
Sure.
Yeah. Oh, thank you, gentlemen. I think I hope there is a new technology aspect. I think at least I am not heard of such a new concept. And I think as Vijay said, instead of looking at back data, we can see the future data, which can help us. I'm sure that it could be a big tool for the Indian industries. Let's explore. And thank you, Mr. Vijay, for spending your valuable time and sharing this new AI tool to the foundry industries. I hope you'll have a big success. And I think people will come back to you. And thank you all, gentlemen, who have been participated, taking your busy time. Thanks for joining. And we also request you to participate in our upcoming webinars and physical seminars. Thank you very much. Thank you all. Thank you all.
Thank you. Thank you again, Bangalore chapter in Chennai.
Thank you, sir. Thank you.